So we want to test the convergence or divergence of the following series. And anytime you see those factorials in there, it should just scream out the ratio test. So we need to do a sub n plus 1 over a sub n and take the limit of that as n goes to infinity. Well, what I like to do is just kind of skip a step. I know it's going to be a sub n plus 1, so 2n plus 2 times n plus 1, and then that's in a factorial over n plus 1 factorial squared. Now we're doing the limit as n goes to infinity. In the actual test you use absolute values, but everything's going to be positive here, so I'm just going to leave them off. And then I just like to flip a sub n. So multiplying by the reciprocal instead of dividing by. So it's a little bit of a shortcut that just saves me a little bit of writing on a step. Alright, now we got a little bit of simplifying to do to see what happens when we take this limit. And it's good to be familiar with how to simplify factorials. So right here, that's going to be 2n plus 2 factorial. This one I'm going to write as n plus 1 factorial, n plus 1 factorial. So I'm splitting up the square because I'm going to be looking for canceling here. This I'm going to write as n factorial and n factorial. And down here, I'm just going to leave it as 2n factorial. So not much simplifying going on yet, but here's where we're going to start to really make our move. So limit as n goes to infinity. I'm going to start writing out these factorials until I see my canceling. What I mean by that, so when I rewrite this guy here, I'm going to have 2n plus 2 times 2n plus 1 times 2n factorial. I'm going to stop there because now I see my cancel. I'm going to do something similar here. I'm going to write this first one as n plus 1 and then times n factorial because I see it's going to cancel there. I'm going to do the same thing with this guy. N plus 1 times n factorial. And now these I don't really need to do anything with because they're going to help me cancel out some of the messy stuff that we got going on. Alright, cancels, 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 cancels. So we did quite a bit of work there. So let's see what we have left when the dust clears. We have the limit as n goes to infinity, and if we want we could multiply these out. So 4n squared plus 6n plus 2 over n squared plus 2n plus 1. If we want, we could do an application of L'Hopital's rule. Some of you might know it already, but if you didn't, there's nothing wrong with using L'Hopital's rule or dividing everything by n squared. There's a bunch of different ways you can go about it. You're going to get 8n plus 6 over 2n plus 2. One more round of L'Hopital's rule. And because we have an infinity over infinity case, we can do this. We get 8 over 2, which equals 4, which is not less than 1, which is greater than 1. So this guy diverges by the ratio test.